Okay, Falcons, third part of our video series. We have to take 6 derivatives, and then we have a question that asks about the 23rd derivative of a trig function on the third page. So let's do them in order. Number 17 says we want to take the derivative of natural log of x squared minus 3. So the derivative of natural log is just to put whatever you're taking natural log of on the bottom, and then its derivative on top. So in this case, we have to work our way kind of in. So if we do that, the natural log of all of this means that its derivative is 1 over natural log of x squared minus 3. Of course, however, we have to use the chain rule. So we're going to multiply this by the derivative of what we're taking natural log of, which is natural log of x squared minus 3, which means on the bottom is going to go x squared minus 3, and then on the top is going to go its derivative, because we have to use the chain rule again. So the derivative of x squared minus 3 is simply 2x. So if I simplify this all out, we're going to wind up with 2x over x squared minus 3 times natural log of x squared minus 3. And that would be our answer. Okay. Number 18, we have log base 8 of x squared plus x. So what I've done is I've put kind of just the general parent function derivative. So we then use that rule, and then we use the chain rule in combination with it. So for this one, if we have the log and we want to take the derivative of it, one's going to go on top, and then on the bottom is x and then natural log of a. So for this one right here, here's what's going to happen. The derivative would be 1 over x turned into x squared plus x, so we're going to have x squared plus x on the bottom as a quantity, and then natural log of a. Well, a was whatever the base was. See how a is whatever the base was right there? So in this case, our base is base 8, so times natural log of 8. However, this is the derivative simply for log base a of x. Our x turned into x squared plus x, so we need to multiply it by that derivative, which is 2x plus 1. So when I get my final answer, 2x plus 1 over x squared plus x times natural log of 8. So there'd be my derivative. Number 19. We have f of x equals 8 to the 4x to the 5th power. So our parent function derivative is the derivative with respect to x of a to the x is a to the x, so notice that part stay the same, times the natural log of a, which is the base of the exponent. So if I do that here, we're going to get f prime of x equals 8 to the 4x to the 5th, which means a of x stayed the same. Natural log of a, well, in this case, 8 is the base, so times natural log of 8. Then this is not a to the x, it's a to the 4x to the 5th. So I need to take that derivative, which 4x to the 5th, the derivative is 20x to the 4th. So times 20x to the 4th. And then, just so we're on the same page here, 20 and 8 can't be multiplied because they have different bases. This one's 4x to the 5th, this one's x to the 4th. So this answer would be more than sufficient. That answer will get full credit. All right? Number 20 says, what's the derivative of the inverse sine of x squared? So here's the parent derivative. If I want to take this derivative, it's going to be pretty much the same thing, except a couple changes. So the 1 on top stays the same. The square root stays the same. The 1 inside stays the same. The minus stays the same. But here's the thing. When we're taking the derivative of the inverse sine of x, notice it's minus x squared. So whatever's inside here, we're subtracting the square of it. So I'm going to now be taking the square of x squared. So I could really simply write it as x squared to the 2nd power. Well, x squared squared is really just another way of writing x to the 4th. So the preferable answer would be 1 over the square root of 1 minus x to the 4th. Then we can never forget, it's really tempting as it is, but we can't, to forget to use the chain rule. This sign was only of x. this sign we're taking it of x squared. So I need to multiply it by the derivative of x squared, which is 2x. So times 2x. We could put that on top, and when we do, our answer is 2x over the square root of 1 minus x to the fourth. There's our answer. Okay? 21. Alright, we have inverse tangent of 5x, and we want its derivative. Again, here's the parent derivative. So we're going to just use this format and use the chain rule. So we're going to get f prime of x equals 1 over 1 plus 5x quantity squared. And then we have to multiply that by the derivative of 5x, which is 5. When I rewrite this, I'm going to get 5 over 1 plus. Now notice the way I wrote it intentionally was that the square applies not only to the x but also to the 5. So 5 squared is 25. X squared is x squared. And so that would be our answer. And no, that cannot be simplified. Yes, I know 5 goes into 25, okay, but 5 doesn't go into 1. So there's no greatest common factor to take out. 22, it says true or false. Natural log of e to the x equals e to the natural log of x power. Well, here's the deal. This one, we went over the identities. Natural log of e to the x, you can use the power rule of logs to show that x comes out front. All right, and the other identity we went over, e to the natural log of x, also simplifies to x. So does x equal x? Pretty sure it does. So this one is actually true. All right. So there's 22. Let's take a look at 23. Ooh, I love this question. It says, if f of x equals cosine of 4x, then f to the 23rd of x equals. Now, this notation, when you see it like this, means the 23rd derivative. Okay, it's occasionally used. There really is not really practical uses for the 23rd derivative, but sometimes the AP people, they put questions like this on the multiple choice just to see if you know how patterns develop and how they can work. So here's what you would do for this one. We know that derivatives for trig functions, for sine and cosine, start off sine, cosine, negative sine, negative cosine. All right. They told us our function, f of x, is cosine of 4x. So if that's the case, here's our function, f, and then we want the 23rd derivative. Well, if this is the function f, does it not make sense that something negative sine blah 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 is going to be the first derivative, and then something negative cosine of 4x blah 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 is going to be the second derivative, and the third derivative, and the fourth derivative, which makes sense because once we've done the fourth derivative, we've come full circle. Now we want the 23rd derivative. This happens in multiples of 4. So do you agree that if cosine of x is the fourth derivative, it's also the 8th derivative, it's also the 12th derivative, it's also the 16th derivative, it's also the 20th derivative, and if that's the 20th derivative, then sine, negative sine would be the 21st, negative cosine would be the 22nd, and what do you know, sine would be the 23rd. So I'm looking for an answer that has positive sign in it, and only two of them do that, which would be A and B. These ones have a negative sign, negative sign. So I know I can eliminate these two answers. From there, let's just find the first couple derivatives, and then we can see if the power is going to be to the 22nd power or to the 23rd. So if f of x equals cosine of the 4x, do we agree that the first derivative would be cosine of 4x, and then the derivative of 4x is 4? So f prime is 4 cosine of 4x. All right, there's the first derivative. The second derivative, f double prime of x, would equal 4 cosine of 4x turns into, oh, I wasn't even worried about what the cosine was. I am sorry. Okay, if I'm taking the derivative of cosine of x, this part should be negative sine. So we'd wind up with 4, and then we'd wind up with a negative sine of 4x. Alright, same thing here. The derivative of negative sine is negative cosine, so negative 4, and then negative cosine of 4x. But then we'd have to use the chain rule again, and so we'd wind up with a times 4. When I multiply the negative 4 and the 4, do I not wind up with negative 16 cosine of 4x? So that's the second derivative. And since this is the second derivative, we can now see that the pattern emerging. The first derivative has a coefficient of 4 to the first. The second derivative has negative 16, which isn't it really just 4 squared? So the third derivative would probably be 4 to the third, the fourth derivative 4 to the fourth, and so on and so forth. So if we want the 23rd derivative, in this case, the pattern we've identified is that we need 4 to the 23rd power, and then sine of 4x because we went through all of this right here. Okay? So 23, definitely answer B. Okay? We'll do 2 more videos after this one.